like synchronous and asynchronous. So the next topic is shift register. So first, trying to understand the shift register, you need to know what is meant by a register. So what is flip-flop? So flip-flop is a 1-bit storage element. So flip-flop is nothing but it is 1-bit storage element. Suppose if I want to store 4 bits of information, I need to make use of 4 flip-flops. Okay, so in order to store this information, we need to make use of registers. So simply register is nothing but group of flip-flops. Register is nothing but group of flip-flops. So if I want to store 4 bit of information, I need to make use of 4 flip-flops. It will look something like this: 1, 2, 3, and 4. So this is a register which is of size 4 bit. So that I can store any 4 bit information starting from 0, 0, 0, 0 to 1, 1, 1, 1. 4 bit of information. So this is a basic concept of register. But the thing that we need to understand is shift register. So shifting means either we can do left shift or else we can do right shift. So let me show you what is meant by shifting. So generally the shiftings are classified into 2 types. One is arithmetic shifting and next one is logical shifting. Again in arithmetic we can do arithmetic left shift, arithmetic right shift. Similarly logical means logical left shift, logical right shift. Now let me give the example of using the same concept of 4 bit. So let us take the example of 1 0 1 0. Now for this I want to perform logical left shift by 1 bit. Means only one time you have to do it. Left shift I need to do. So take 1 0 1 0, which is a register which is storing 4 bit of information, or else you can simply say register is nothing but group of flip-flops. I want to perform left shift by 1 bit position. So if you perform left shift, this one will go away, whereas this 0 changes to 1 bit by left. Here it will be 1 and this one will be 0. Then what about least significant bit? Should I fill it with 0 or 1? Least significant bit.
1.
Least significant bit should always be filled with 0. This one has gone away, so we can't do anything for this. So this is the equivalent that we got if we perform logical left shift by 1 bit position. Next, for the same question, you try to perform logical right shift and tell me the answer. 1 0 1 0 right shift I want. 1 0 1 0 right shift, logical right shift I want to do. Logical right shift by 1 bit position. See, this one comes here 0. This one will be 1. Now here most significant bit is empty. You need to fill this one with 0. Earlier we have filled the least significant bit with 0. Now you have to fill most significant bit with 0. So what is the equivalent? This is a given question. 1 0 1 0 equivalent is 10. Whereas 0 1 0 1 equivalent is what? Decimal equivalent I want. 8 4 2 1. This is 5. Whereas if you did logical left shift, what was the answer you got? For logical left shift for the same question 1 0 1 0, it is 0 1 0 0. So I got 0 1 0 0. Here the given question is 10, but after performing logical left shift by 1 bit position, you are getting answer as 4. Okay, so this is how you need to perform logical left shift and logical right shift. Now similarly, you tell me for arithmetic left shift and arithmetic right shift for the same question. Arithmetic left shift. Arithmetic left shift is same as logical left shift only. So if you try to perform the arithmetic left shift, you will get the same answer as logical left shift. Both concepts are same. So again, I'm taking a register which is of size 4-bit. If I try to perform left shift by 1-bit position, this 1 will go away and here it will be 0 and this one will be filled with 1. Next bit will be 0 and least significant bit should always be filled with 0. So equivalent for this is 10, the equivalent for this will be 4. Now the special concept here is arithmetic right shift. This is a bit different. Arithmetic right shift. Same question 1 0 1 0. This is a question which is given to you. Perform arithmetic right shift by 1-bit position. So here the thing which you need to do is first you need to preserve the most significant bit. So most significant bit is preserved as it is, and next again try to shift most significant bit by 1-bit position. So here the 1 comes here it will be 0, here it will be 1. So equivalent for this will be 10 and equivalent for this will be how much? 8 4 2 1. So 8 plus 4 is 12, 12 plus 1 is 13. So arithmetic right shift is a bit different compared to all the arithmetic left shift, logical left shift and logical right shift. So first you need to understand these kinds of shiftings before trying to understand what is meant by a shift register. So can you tell me the answer now for the another question? Tell me the answer for 1000. Tell me logical left shift, logical right shift, arithmetic left shift and arithmetic right shift. Tell me the answers for 1000. Shift it only by 1-bit position. Rule number 38. Samira, are you there? Kuldeep, answer.
0 0
First answer, logical left shift.
0 0.
All zeros. Next, logical right shift.
1100. 110.
Logical right shift.
0 1 0 0
0 1 0 0. Next, arithmetic left shift.
0 0
Next, arithmetic right shift.
1 1 0 0
1 1 0 0. Correct. So for arithmetic right shift, first MSB should be preserved and again you need to shift. So the given question is 1000, which is 8, and the shifting you got as 0. This is 4, this is 0, and this is 12. Shift registers. Primary function of a storage register is to store information until they are transferred to the other digital circuit. So generally register is used for the sake of storage. Suppose if you want to shift the content which is present in it, you need to go for a concept called as shift register. So the content gets shifted whenever you are trying to apply a clock pulse. So see here, another type of register is called as shift register. So one is storage register, next one is shift register. So generally they are classified into types as SISO, SIPO, PIPO and PISO. So here SISO stands for serial in, serial out. S stands for serial. P stands for parallel. And here I stands for input. O stands for output. So this is serial input, serial output. Next one is serial input, parallel output. Third one is parallel input, parallel output. And fourth one is parallel input, serial output. So in order to store the content in the register, we need to understand a concept called as loading and storing. So load, store. Have you heard about the terms called as pushing and popping? What is push and what is pop? In C language, you will hear about this topic, push and pop.
Removing and adding element.
Tell me what is pushing? Means you are storing or you are retrieving?
Storing.
Storing.
Pushing is nothing but storing. Popping is nothing but
Removing.
Okay, retrieving or removing. So here also the same thing which we need to do for all these different kinds of registers. So serial input, serial output. So the data is loaded into and read from the shift register in serial manner. So before this, you need to know what is serial and what is parallel. So suppose if you observe like two transmitting devices are there, like transmitting end and next one is receiving end. If it is serial, only one single line will be there. Suppose I want to transfer the information 1010 from transmitting end to receiving end. This is one thing, and again one more is transmitter, next one is receiver. Now I want to transfer information parallelly. Same content I want to transfer 1010. This is of size 4-bit, so I'm connecting 4 lines. You can call these lines as wires or bus. Wire or else bus, same, which is carrying some amount of information. So in this, which one is serial, which one is parallel? Among the two diagrams, what is serial and what is parallel?
Sir, first one is serial, second.
First one is serial, correct. Next one is parallel. Which one will be faster, serial or parallel?
Parallel.
Parallel will be faster compared to serial. In serial, information will be transferred bit by bit. So bit by bit, information will be transferred. Whereas in case of parallel, all the bits will be transferred simultaneously, like 0, 1, 0, 1. So all the 4 bits will be transferred simultaneously from the transmitting end to the receiving end. It is called as parallel. So that's the reason it will be faster. Whereas if it is serial, bit by bit. So again, it depends upon like left shift or right shift. So here first, this 0 bit will get transferred. After that, 1. Next it will be 0 and 1. So information will be transferred bit by bit in serial, whereas parallel for simultaneously all 4 bits will get transferred. So see here now. So the data is loaded into and read from the shift register serially. So serially is nothing but information is getting transferred bit by bit. Next, this type of shift register accepts data in 1 bit at a time on a single input. Just now which I told you, bit by bit information will be transferred. So serial input, serial output, which is nothing but shift right. Again in this you can understand what is meant by shifting right side and what is meant by shifting left side. Now this should be implemented by means of flip-flops. So shift right register. See, observe this diagram. Shift right. So take a content called as 1011 and you are trying to shift this one right side by 1 bit position. Just now I told you how to shift left and right. Now the same concept you need to implement it by means of flip-flop. So register is nothing but a group of flip-flops. As I want to store 4 bit of information, I'm making use of 4 different kinds of flip-flops. So here I'm going with an D flip-flop. So 4 bit, 4 flip-flops, FF1, FF2, FF3 and FF4. So inputs are D0, output is Q0. Here input is D1, Q1, D2, Q2, D3 and Q3. So I want to transfer information serially. So here the given question is SISO. Input should be applied in the form of serially and output should be taken in the form of serially only. So serial input and serial output means you are applying input at D0 and you are seeing the output at Q3. So as we are going with D flip-flop, what is the characteristic equation of D flip-flop? Qn plus 1 is equal to characteristic equation for D flip-flop. Qn plus 1 will be equal to D. Means if you apply 1 at D0, Q0 will be 1. If you apply 0 at D0, Q0 will be 0 only. So I want to transfer 1011. So first with which one enters, like MSB or LSB? According to this diagram, which bit first enters into the flip-flop? Least significant bit or most significant bit?
LSB.
Correct. Least significant bit enters, which is nothing but this 1 will enter first. Least significant bit. So initially I'm assuming the content which is present in Q0, Q1, Q2, Q3 as all zeros. Now, is this synchronous or asynchronous clock?
Synchronous.
So this clock is synchronous. Simultaneously you are applying clock for each and every flip-flop. So when the first clock pulse you are applying, at the 0th clock pulse the content is 0. Now when you are applying the first clock pulse, least significant bit enters into the flip-flop. Means this 1 will be given to D0. If you are applying 1 to D0, what will be Q0?
1.
What will be Q0?
1.
If D0 is equal to 1, Q0 will also be equal to 1. According to the characteristic equation, Qn plus 1 will be equal to D. So now the 0 changes to 1. So after first clock pulse, the content is 1, 0, 0, 0. So you can observe here in this diagram. Initially the content when 0th clock pulse is applied, all are zeros. When first clock pulse is applied, you are applying least significant bit to D0. So the D0 will be given to the output which is Q0. So that now the content is 1, 0, 0, 0. Now tell me what will happen when you apply next clock pulse, changing 1 to 2. What will happen? Which bit enters? First bit is already completed. Now the next bit 1 will be applied to D0, and this 1 is applying at D1. So if you are applying 1 at D1, what will be the output? This changes now to 1, whereas this 0, 0 will be constant only. So as you are applying 1 from the external input, here again this one will be 1 only. Okay, so the new content after the application of second clock pulse is 1, 1, 0, 0. So it is 1, 1, 0, 0. Now try to apply the next clock pulse which is 3. So 2, I'm changing it to 3. So 2 bits are already completed. So remove these 2 bits. Now this 0 you have to apply at D0. So if you apply D0, output Q0 will be 0. But before that only, as it is synchronous, this 1 will be given to D1. And this 1 will be given to D2. When you are applying 1 to D2, this 0 changes to 1. And if you apply D1, this output changes to 1. And if you apply D0 here, which is 0, this output changes to 0. So after the application of third clock pulse, the content which is present is 0, 1, 1, 0. So 0, 1, 1, 0 is present. So simply it is getting shifted by 1 bit position for the application of clock pulse. Now can anyone tell me for the last case, when you apply the fourth clock pulse, what will happen? Fourth clock pulse, if you apply this one which is Q2 gets changes to Q3 and Q1 enters into Q2, Q0 enters into Q1. Whereas this new bit position will be taken from the serial input that you are applying, which is nothing but most significant bit, MSB. So in order to store the information, it is taking 4 clock pulses in, serial out, serial input, serial output. You are applying input serially and taking output serially only, that is bit by bit. So this is all about serial in, serial out. Is this shift right or shift left? What you are doing? Shifting right or left?
Shifting right.
You are shifting this one right. The same SISO can be explained for shift left also. So observe this diagram and tell me again same input combinations, but direction got changed. Now I want left shift. So here which bit will enter now, LSB or MSB?
MSB.
So most significant bit will enter for left shift. So apply 1 here. So before that you need to assume the content is all zeros. So initially all the content is 0. Now application of the first clock pulse, this first bit is entering. So if you apply 1 at D0, this one will be 1. So the content now will be 0001. So 0001. Now after the application of clock pulse, it is getting shifted left by 1 bit position. So left by 1 bit position. Now this new one will be loaded with the serial input that you are applying. For the next clock pulse, again left shift by 1 bit position, and here it gets loaded with the serial input which you are applying. Next, by the application of 4th clock pulse, it gets shifted by 1 bit position, and this one will be filled with the input which you are applying externally. So again it takes 4 clock pulses in order to store the content. So shift right and shift left is same, but try to understand the diagram. Shift right, next is shift left. So as it is 4 bit, so I'm making you the 4 flip-flops. So this is all about serial in, serial out, and Verilog code is not there for you. Next, what is serial in and parallel out? You are applying inputs serially, but you are taking output parallelly. This is called as serial in, parallel out. Observe this diagram now. What is the difference compared to SISO? Serial in, parallel out. There only directly are connecting from Q1 to D2, Q2 to D3, Q3 to D4. But here parallelly I am taking output. Parallelly I am taking output, so that's the reason draw a line here. Means I am taking output parallelly from Q1, Q2, Q3 and Q4. Whereas you are applying input serially. Serially means only at the first flip-flop you are applying input. Whereas in SISO you are applying input serially and only at the Q4 you are taking the output. So output is seen only at Q4 for serial output, whereas now this is parallel out. So that's the reason at the output of each and every flip-flop you need to see the output. Now can anyone explain me this by applying the inputs? Apply inputs and tell me what will happen. Initially content is 0. You know this one. Before the application of clock, initially content is 0. Now when the first clock pulse is applied, LSB will enter or MSB will enter? Least significant bit or most significant bit?
LSB.
Least significant bit will enter. So D1 is equal to 0. When you are applying D1 is equal to 0, Q1 will also be 0 only. Okay, so after the application of first clock pulse, again content is 0, 0, 0, 0. Done. Next, try to apply the second clock pulse. When you apply the second clock pulse, now the next bit enters, which is 1. So before this, it should get shifted by how many bits of position? 1 bit or 2 bit? By 1 bit position, the contents get shifted. Now this 0 is applied to D2 and Q2 is applied to D3, Q3 is applied to D4. Okay, so simply it is getting shifted by 1 bit position. Now it will take new input which is 1, so that this one will change to 1. So the content is 1 0 0. So directly you can write like this. So initially when the clock pulse is 0, all the outputs are zeros. When first clock pulse is applied, so the input that I am applying is 1 0 1 0. So first bit will enter. So here it will be 0 and this is getting shifted. So 0, this is 0 and this is 0. Next, when you apply the second clock pulse, when you apply second clock pulse, this content is getting shifted by 1 bit position, whereas the new space will be filled with new value which is 1. Next, when you apply third clock pulse, this content is getting shifted by 1 bit position, so it will be 1 0 0 and the 1 space is vacant. This one will be filled with new content, that is 0. When you apply fourth clock pulse, this is getting shifted by 1 bit position and new position will be filled with the new input which is 1. So 1 0 1 0 will be stored after 4 clock pulses. So all the concepts will be same, but at least you need to try to understand like whether it is performing left shift or right shift. This is about serial in, parallel out. Now parallel in, parallel out. Observe the difference here. So parallelly we are applying inputs for each and every flip-flop. As this is parallel in, at each and every flip-flop I am applying the input, and at the outputs of each and every flip-flop I am seeing the outputs. Whereas in case of serial in, serial out, applying input serially and taking output only at the last flip-flop. If it is SIPO, applying input serially at the first flip-flop, whereas you are observing output at the outputs of each and every flip-flop. Now this is parallel in, parallel out. Applying inputs parallelly to each and every flip-flop and observing the outputs parallelly at the outputs of every flip-flop. Now among these three, which one will be faster according to your assumption? Which one will be faster among SISO, SIPO and PIPO?
PIPO.
PIPO will be faster compared to all the three which you have seen. So initially, before the application of clock pulse, content will be 0, 0, 0, 0. Now when you apply the first clock pulse, simultaneously you are applying all the inputs. Now you are applying D0 as 1, D1 as 0, D2 as 1 and D3 as 0. Now immediately at that moment of time only output changes to 1. Here again it will be 0 only. Here it will be 1. Here it will be 0. So you can observe the outputs as 1, 0, 1, 0. Within a single clock pulse, you are finishing all this work. Whereas in the previous case, for each and every bit serially as you are shifting, you are trying to apply more number of clock pulses. Whereas for parallel in, parallel out, within a single clock pulse, if you apply the input, you will get the output. This is about PIPO, and next one will be PISO. So you are applying inputs parallelly and output is taken serially. Serially means at each and every flip-flop or at the last flip-flop?
At the last flip-flop.
Correct. At the last flip-flop we need to see the output. This is the difference. But for PISO, mostly this one will be asked in exam. For this one, separate combinational circuit will be used. See this one. So the advantage with parallel in, serial out is we can shift, whereas we can load. Means loading can be done, followed by shifting can also be done. Can anyone explain me this? I can do shift operation, I can do load operation. If I want to shift is active high or active low? Shift is active high or active low? If bar is not there, it is active high. And load bar means active low. So what I'll try to do is, first I'll try to apply 0 here. So tell me what will happen if I apply 0. This is 0. After passing through this NOT gate, it will be 1. So at this point it will be 1. At this point it will be 1. At this point it will be 1. Okay, next. This 0. This 0 is connected to this line. So here you are applying 0. Now tell me the outputs of this gate. B into 1. Here it will be B. C into 1. Output will be C. D into 1. It is D. Next. See the outputs of gate G4, G5 and G6. 0 into anything. So you are applying Q1 here. This is Q2. This is Q3. 0 into anything will be 0 only. Try to add them. B plus 0 will be B. C plus 0 is C. D plus 0 is D. Now what is happening here? You are loading or shifting? Loading or shifting? You are activating load bar. So you are loading the content. If you apply 0 here, it will load the content. Whereas if you make shift as 1, it will shift the content present in the flip-flop. Okay, this is one case. So you need to explain this in the form of cases. So case number 1, you are applying load bar is equal to 0. Means you are activating load, you are disabling shift. As you are activating the load pin, all the contents of A, B, C and D are getting entered into the flip-flop. This is one thing. Now you make shift is equal to 1. For that case, you tell me now. Apply 1. So 1 after passing through the NOT gate, it will be 0, 0, 0. Here it will be 1, 1, 1. Next, B into 0, 0.
0 only, 0.
Next, 1 into Q1. How much? 1 into Q1 will be Q1. 1 into Q2, Q2, Q3. Here it will be Q1, this one will be Q2, this one will be Q3, which will be applied at D2, D3 and D4. So what you are doing here, shifting or loading?
Shifting.
Correct. We are doing shifting. So just if you know this diagram, you can explain this parallel in serial out shift register easily by taking two different assumptions. So once again, you try to understand all these asynchronous inputs and flip-flop that we have seen like preset and clear, and be familiar with active low and active high. So if there is no bar, it will be active high. Suppose if I write as shift bar, this is called as active low, whereas this is active high. Just remember like this. If there is no bar, it is called as high. If there is a bar, it is low. So this is about shift registers. 4 shift registers are there, and one more thing is there, which is universal shift register. That one will be explained by rule number 1. Hussein, are you ready? Rule number 1 will explain universal shift register.